Once again, good morning, and we are now in the first topic for the second quarter. Our topic this week and next week will be all about variations. And so far, as what I've mentioned, this is the easiest topic and the shortest among all chapters. We only have four lessons for this chapter. Now let's start with the first lesson for chapter 3. This is about direct variation. Now, to start with, let's recite, wait first. Oops. I'm sharing the last one. Okay, here. To start with, let's recite our memory verse. It's found in Proverbs 11, verse 24. It says, "Give freely and become more wealthy. Be stingy and lose everything." This is a parallel verse with, I think it's very common to you. The more you give, the more you receive. Give me a moment. There. Now, RMVC boosters is very much related to our memory verse today. It says, the more you give, the more blessings you receive. Our memory verse tells us that we will be blessed abundantly if we give more. Now, do you have any experience on this? You can share a brief glimpse of your story. And at the end of today's lesson, we'll be able to illustrate situations involving direct variations. Next, translate a variation statement into a table of values, a mathematical equation, a graph, and vice versa. And lastly, we'll be able to solve problems involving direct variations. So let's start. Now let's talk about paper pollution. You think about paper pollution. If more papers are used, what else will also increase? Like if we use more papers, more trash on papers will also be seen, right? And if papers are recycled, what will also decrease? Like if you recycle scratch papers or if you recycle used papers, then trash will also decrease. The University of Southern Indiana stated that each ton, that's around 2,000 pounds of recycled paper, can save 17 trees, 380 gallons of oil, 3 cubic yards of landfill space, 4,000 kilowatts of energy, and 7,000 gallons of water. This represents a 64% energy savings, a 58% water savings, and 60 pounds less of air pollution. So let's save our papers. Let's not just once we are, sometimes I'm guilty of this. My kid would always ask me for a paper. I am giving a clean sheet of paper just for something to scribble. I could have given the scratch next time. Now, today let's talk about direct variation. Now, what is direct variation? Direct variation states that if y varies directly as a quantity of x, so if y increases, then x increases. If y decreases, then x decreases. So you see the arrows are the same. If one variable will increase, then the other variable will also increase. If one variable would decrease, then the other variable will also decrease. The equation of a direct variation is written as y equals kx. Y is called our dependent variable, while x is called our independent variable. And remember, k should be a non-zero constant of variation. Let us have some examples for direct variation. Example, here, more paper use, if we use more papers, then more trees will be cut. This should be the second one. Another, the longer distances you travel, the higher the transportation fare will be, right? So we expect that the fare from Valencia to Malaybalay is less than the fare from Valencia to Cagayan. And we also expect that the fare from Valencia to Cagayan is higher than the fare from Valencia to Malaybalay. Why? Because of the longer distances. The next one, let's have more products sold. The more products you sell, the more your income is. Again, the more products you sell, the more income you will have. Another, the more hours you spend in writing, then you'll have more pages written. Or let's go back to our venture activity. The fewer papers that you will use, then the lesser air pollution or paper pollution you'll have. Or less vehicles, then less chances for air pollution. That is how we describe direct variations. Now let's see, how are we going to translate direct variations? In an English sentence, we can write this as y varies directly as x. Or another way to state it is y is directly proportional to x. Another way, y is proportional to x. These three statements will all mean when y increases, x also increases, or the other way around. If x increases, then y increases. Remember, our equation of variation is y equals k times x. Now, what is k? K is called our constant of variation. Now, what is a constant of variation? It is a non-zero number that tells us of the proportion of change that will happen when one variable will increase. Example, here, in our first exercise, you'll translate the following statements into symbols. And let's have k as the constant of variation. Remember, y varies directly as x. So let's change y and x. For example, in the first one, ready? I'll first start with this example. The number of candies that may be contained in a jar varies directly as the size of the jar. So we write in a mathematical sentence that C equals KJ. If we read it, the number of candies varies directly as the size of the jar. Now, prepare your chat box. Let's see. How about the second one? How will you write it? The bus fare, F, is directly proportional to the distance covered by the bus. Now, how will you write it in a mathematical sentence. Yes, it's correct. F equals K times D. Next, number 3. The income of a store depends on the number of products sold. How will you write it in mathematical sentence?
I
Yes,
equals
AP.
P K P.
Very good. I equals KP. How about the next one? The cost of fish varies directly as its mass in kilograms. Oh,
E
very
equals
good,
K
Kyle.
M.
And Isabel, very good. C equals K times M. The next one. An employee's salary depends on the number of days he worked. How will you write it? Ready in the chat box? Very good. S is equal to KD. Very good, Carmela. Next, the length of a person's shadow at a given time varies directly as the height of the person. Very good. L equals K times H. And the last one, the volume of a cylinder varies directly as its height. V equals K times H. Very good. Now, let's go to the next one. This time, we will solve for the constant of variation. Now, how to solve for the constant of variation? Here is the problem. We find the constant of variation and the equation of variation. Now, how do we solve for the constant of variation? The given is y equals 26 when x equals 36. We remember our general formula. That's y equals kx. The first step is we will substitute the values of y and x in order to solve for our k. So we write 26 equals k times 36. Next, we divide both sides by the coefficient of k. So we divide both sides by 36. So we have k equals, let's reduce, 13 over 18. This is now our constant of variation. Next, how do we write our equation of variation? We go back again to our general formula. Then we substitute the value of k. So we have y equals 13 over 18x. Do you have any questions? If there's no question, let's proceed to the next example. Ready? Okay, I'll give you 30 seconds. Solve for the constant of variation. Then type it in our chat box. What is the constant of variation? If y is 20 when x is equal to 4. Ready? Oh, very good. We still need the constant of variation. The constant of variation is, oops, remember, I'm still asking for the constant of variation, or k. I'm not yet asking for the equation. Now let's substitute. Y is equal to k times x. Let's substitute. Very good, Carmela. 20 equals k times 4. Then you need to simplify it. Divide both sides by 4. So what's our constant of variation? K is equal to 5. Very good, AP and Ali. Now, let's write our equation of variation. Remember, y equals kx. What's the value of our k? Y is equal to 5x. This is our equation of variation. Very good, everybody. Now, let's have another exercise. In our next activity, I'll be giving tables and graphs, and you will check if the table of values or the graph represents a direct variation. Now, what's one way to check if it's a direct variation? Actually, in a direct variation, we have what we call common difference. We say, what's the difference from one number to another number? If the common difference is consistent, like for example, if the gap is by 2, so 2, 4, 6, 8, 10, then it's possible that it's a direct variation. Example here, 1, 2, 2, 3, 3, 4, 4, 5. Another at the bottom, 500, 1,000, 1,500 plus 500, 2,000 plus 500, 2,500. That's one way to see. But the best way is to solve for the constant of variation. Then we will check with using another number if it's correct. Example, let's check with 1 and 500. So y equals kx. 500 equals k times 1. So the value of our k is 500. This is now our constant of variation. Let's solve for the equation. The equation of variation is y equals 500x. Now what will happen? Let us try to substitute the x and let us see if it will give us these answers. Example, number 1, for 2. If x equals 2, then y equals 500 times 2. So y equals 1,000. Very good. It's correct. Let's try another one. For 5, if x equals 5, then y equals 500 times 5. That's 2,500. Very good. It's correct. Since these are correct, then we say that the table of values represents a direct variation. Any questions? Let's go to the next one. Ready? Let's check. Okay, here we have 1 and 80. What's the next? 2 and 160. 3 and 240. 4 and 320. 5 and 400. Let us check. We find first the constant of variation. Now in the chat box, can you tell me what is the constant of variation? Ready? Let's substitute. That's 80 equals k times 1. What's our constant of variation? Very good. Our constant of variation is what AP said. It's k equals 80. And Isabel wrote our equation of variation. Our equation is y equals 80x. Now let us check if it's a direct variation. Ready? 80 if x equals 3. Let's check. Then y equals 80 times 3. That's 240. Very good. Correct. You want to try again? Here, how about 5? 80 times 5. The answer is 400.
400.
Therefore, it is a direct variation. Now let's go to the next one. Ready? Can you tell me, is it a direct variation or not?
No.
Or why not, AP?
They cannot. Some of them cannot be divided.
But you see, 2, 2, 2. At the bottom also, 2, 2, 2. Now, again, how to know it? Because you see, you cannot just say that it's not a direct variation. You need to have a proof. So how will you prove it? You will solve for the constant of variation first. So we say y equals kx. So let's start with the 2. 7 equals k times 6. Divide all by 6. So k equals 7 over 6. If it's a direct variation, then we can have it as y equals 7 over 6x. Let's start substituting with this one. Ready? If x equals 12, will y be 13? Let's check. Y equals 7 over 6x. Let's substitute x. So we have 7 over 6 times 12. 1, 2. 7 times 2 is 14. But you look at this. This is 13. Therefore, this is not a direct variation. Now, any questions before we proceed?